All right, guys, so welcome to experiment number 3. Our main focus in this YouTube video is on the centrifuge. The centrifuge is very instrumental in biochemical separation. Without the centrifuge, you cannot perform biochemical separation. So what is a centrifuge? A centrifuge is a machine that is driven, has an electric motor that places an object in rotation around a fixed axis. And let me draw this for you guys right here. So if we were to draw it, pointer options. So this is the axis of rotation, and then you have your sample which rotates around this fixed axis. Okay, and this force is called the centrifugal force. Now, let's go back here to the pointer. It applies a force. This force, which is called centrifugal force, it causes more dense molecules to sediment and form a pellet. Lots of words in here, guys. More dense meaning more compact molecules. Mass per volume. To sediment means to move to the bottom of the tube. Highly dense molecules, let's say molecules that are more dense than water, that have a higher density than water, they sediment or they move to the bottom of the tube via gravity, and they form a pellet. So let's understand here what a pellet means. So this is a centrifuge right here. Before centrifugation, let's say you have a solution where you have a precipitate in this solution, maybe it's casein, as in our experiment. After you centrifuge, the casein will sediment. Okay, the casein, because it has a higher density than water, it will sediment to the bottom of the tube. Okay, it will form a solid at the bottom of the tube after centrifugation. Now we call this solid the pellet. This is the pellet, the casein pellet. Above the solid, we have the supernatant. The solution above the solid, the pellet, is called the supernatant, which has other molecules. So sometimes you need the pellet and you don't need the supernatant. Sometimes you need the supernatant and you don't need the pellet. Sometimes you need both, depending on the experiment. So the pellet is the solid part, is the solid molecule at the bottom of the tube. Now, precipitation via the centrifuge, there are two main ideas. There are two main ideas that explain the centrifuge. The first one is sedimentation, which we touched on a little bit earlier. And then the second point is the speed of the centrifuge, which can be measured in RCF or RPM. So let us dig deeper here. What is sedimentation? As we mentioned earlier, guys, sedimentation, if we look at this picture, sedimentation basically is the movement of molecules via gravity, the movement of highly dense molecules, let's say denser than water, to the bottom of the tube. They sediment to the bottom of the tube. Okay? So it is a process by which more dense, more compact particles settle to the bottom of a column in a gravitational field. For example, if we have a molecule that is more dense than water, a solid that is more dense than water, if you give it 3 or 4 or 5 days, it will sediment. But we want this process to go faster. And this is what the centrifuge does. It speeds up the sedimentation process. Now, the rate of sedimentation depends on the mass and the shape of the molecule and on the sedimentation force or speed. And here, guys, very important, the shape of the molecule. Okay, the shape of the molecule. For example, if we have a molecule that is spherical, so let me draw this for you guys. If we have a molecule that is spherical, that looks like it's ball-shaped, versus a molecule that is linear, maybe it's DNA, okay? Then the molecule that is spherical, it will move faster, it will sediment faster than a linear molecule. And I'm sure you guys know why, okay? Because the linear molecule, which moves slower, is gonna hit the sides of the tube. So its movement to the bottom via gravity will be retarded. It will move slowly, it will be obstructed. Whereas the ball or the sphere, it will move faster because it will have little friction with the sides of the tube. Now we can measure the strength of centrifugation via 2 units, RPM or RCF. So let's look at RPM. I'm sure you guys have seen, RPM in your car, in the window of the car, not the window, but I forgot what the front of the car is called, but it measures basically, okay, so what it measures basically, guys, is the speed of the engine, and RPM stands for, or can stand for, revolutions per minute, rotations per minute, or rounds per minute, but most commonly revolutions per minute. Okay? So it's the measure of the number of rotations, revolutions, rotations, rounds in 1 minute around a fixed axis. So this is called here, guys, if you look down here, this is called the rotor. This is the rotor. It's inside the machine. This is what goes in circle, what rotates. So it basically measures how many rounds the rotor goes in 1 minute, how many revolutions in 1 minute. Very simple. Now let's look at RCF. RCF stands for relative centrifugal force. Relative centrifugal force. G here, or G force. G stands for G force, which is the acceleration of gravity. Okay, so RCF, it's measured in multiples of G. Okay. So how strong is the rotation in terms of gravity? Okay, so for example, if you guys look at this one, 10,000 times stronger than gravity. Okay, 10,000 times, the speed of the rotor is 10,000 times larger than gravity, 20,000 times larger than gravity, etc. And we can switch back and forth between RPM and RCF. So if we're given RPM, we can go back and figure out the RCF using this formula, and vice versa. If we're given the RCF, we can figure out the RPM. Okay. But we have to know what R is. So let's look at the picture right here. So R is measured in centimeters, and it is the radius of the rotor, indicated in red. So it is the radius of the rotor. You guys look down here. This is the rotor. The radius is measured from the center to the bottom of the tube. And in this case, it comes up to 240 millimeters as indicated here. That is the radius. Now, there are two types of centrifuge rotors. One is called the swinging bucket, and the other one is called a fixed angle. So the swinging bucket, you have your sample, your tube is basically swinging 90 degrees to the axis of rotation. Okay, 90 degrees to the axis of rotation. And we have this in the large centrifuge that we're going to be using today. Okay? We also have a fixed angle centrifuge where your tubes are basically fixed in place and are 45 degrees to the axis of rotation. And of course, guys, we didn't mention it here, but each one of these have their own specific advantages and disadvantages. So for example, the swinging bucket, it can go, if you want to go to very low speeds, then you use the swinging bucket. And if you want to go to very high speeds, you choose the fixed angle. And also the swinging bucket is better for isolating the pellet. It's better for separating the pellet. Now, before we use the centrifuge, before we turn on the machine, we have to balance our tubes. Okay, we have to balance our tubes. What does that mean? First of all, if we don't balance our tubes, what's going to happen, guys, is that the machine will be damaged. You will hear a big, a large sound that indicates that the machine is going to be destroyed. So you have to be careful, guys. Okay? Otherwise, the machine will get damaged. So how do we balance? How do we balance the tubes? We can balance, or we have to balance, in terms of two things: placement in the centrifuge and volume. So placement, position, and volume. Let's talk about placement. The way we place them in the centrifuge. So let's say here we have orange tubes and the green tubes. So the orange tubes are the same. They have, let's say they have milk, for example. The green tubes, they have water. So you can see here the orange tubes are balanced. They're balanced in terms of position. They are opposite to each other. There is equal spacing between them. The green tubes, which contain water, they're also balanced because they are equally spaced. All right, guys? So that's how you balance in terms of placement or position. They're opposite to each other, two tubes. If you have three tubes, that's how you balance them. We also have to balance in terms of volume. And this indicates, guys, that they have to have the same volume. They're opposite to each other. they have to have the same volume as indicated here. So these two are not balanced. And of course, preferably, okay, they have to have the same type of liquid also, same type of liquid. If it's water, we use water. If it's milk, we use milk. And we can use also water to balance milk because milk is mostly water, as shown here in the next slide. All right, guys. So now when we do this experiment, so this is how we do it, guys. We're going to be using this large centrifuge. So you can see here, we are balancing in terms of placement. Balancing in terms of placement. So we have our large tubes. This is a swinging bucket type of centrifuge. They are placed opposite to each other, so they are balanced in terms of position or placement. They also have the same level of liquid. And as I mentioned earlier, you can balance the milk with water because milk is mostly water. So I don't know if you guys can see here, but they have the same level of water or the same level of liquid, to say it correctly. All right, so they are balanced in terms of placement and in terms of volume. Finally here, guys, when you guys look at the centrifuge in the class, this is what you might see. Okay, just to show you guys how to read the centrifuge or how to read the numbers on the centrifuge. So indicated here 6,000, that is the speed of the centrifuge. Is it multiplied by G? Is it rotations per minute? So here you can see here, guys, that we chose, it is multiplied by G. 6,000 greater than G because we have, I don't know if you guys can see it, but we have, there's a light on the G side. Okay, RPM is dim, it's not lit. Okay, so 6,000 multiplied by G. We also have, so here indicated the speed, the time, 5 minutes. The temperature is 0 Celsius. Okay, the temperature that we're going to be using today is 0, for the most part, 0 Celsius. And these values, guys, I don't want you to worry about them. Don't worry about these values. Okay, they're not that important. Anyways, guys, I wish you guys all the best and good luck with your experiment.